Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a short tutorial on face detection in OpenCV, and I'm going to be comparing two methods, Haar, Cascades, and also deep neural network. Let's get started. As I said, this video is going to be a tutorial on face detection in OpenCV. Face detection is the process of identifying and locating human faces in digital images or videos. It doesn't recognize who the person is, just where the face is. It's used in everything from camera autofocus to surveillance to social media filters. Some of the examples are like your phone unlocking with your face, or apps tagging people automatically in photos. One of the earliest and fastest methods is called the Haar Cascade classifier, introduced by Viola and Jones. It's based on handcrafted features like edges and lines captured by something called Haar-like features. It slices a small window across the image at multiple scales and uses a decision tree trained on thousands of positive and negative face examples. This method is fast and lightweight and also works well in controlled lighting, but it also struggles with variations in angle, lighting, and occlusion. The second method that we're going to be working with is deep learning. Modern approaches use deep learning for better accuracy. OpenCV's DNN module supports models like the ResNet-based face detector from the single-shot detector family. It uses a CNN trained to identify faces at various scales and orientation and is much more robust than Haar Cascades. So the DNN is more accurate and tolerant of variations and also works better on angled, low light, and also partially occluded faces, but is heavier and slower, especially on CPUs. Here's the architecture of the DNN that we're gonna use in OpenCV. It uses a lightweight variant of the original ResNet architecture, which is designed for speed rather than depth. So it only uses 10 layers, and it acts as a feature extractor processing the input image into deep convolutional features. And the single shot detector or SSD is used for bounding box regression and classification. It adds convolutional layers on top of the feature maps to predict bounding boxes and also predict class confidence scores, which is in this case just face versus not face. So the input is a 300 by 300 RGB image blob, which is mean subtracted, and output is a detection matrix. Let's go to Python and see how the codes work, and I'm going to explain more what's happening there. Let's first start with the Haar Cascades. So we first import OpenCV, and then here we're going to be loading the Haar Cascade face detector right here. And then here we're going to be starting the video capture, which would open our default webcam, device number 0, and then cap will be used to read the frames from the camera. And then here is the main loop, which keeps running until the user exits, which is typically done by pressing Q, as you can see here. So here we're going to be capturing one frame from the webcam, and then RET here is true if successful, and frame here is the actual image captured in color. So Haar Cascades works best on grayscale images, so we're going to be also converting the RGB images into grayscale images, as you can see here. And then here is where the actual detection is going to happen. So the grayscale image is going to be input to the model, and then here is the scale factor, which is how much the image size is reduced at each image scale. And then using this input, we're going to be specifying how many neighbors each rectangle should have to be considered a valid face. If you set this to a higher number, it's going to be less false positive. So this algorithm is going to be returning a list of rectangles, which are going to be represented with X, Y, W, and H, which represent a face bounding box. So here we're going to loop through each detected face and then draw a blue rectangle around the face on the original color frame. And then here we're going to be displaying the frame with the rectangle in which there is a face. I should also add these two lines, which would properly release the webcam and close the window. I just added these two. Let's run it and see what happens. So as you can see, it has appeared here, and I'm right here. There are some rectangles that also appear here, which is not right, which appears here, which wasn't right. If you see it again, okay, it's not appearing anymore. It's not bad at all, right? As long as the lighting is good, I think this algorithm is going to work very well. that rectangle is again appearing. Anyway, let's go to the second method. So we first import OpenCV, and then we're going to be loading the pre-trained model that we're going to be using. And then here we're going to be opening the default webcam, index 0. This will be our video stream. And then here in the while loop, we capture a frame from the webcam. RET is true if the frame is successfully read. And then the frame contains the actual image from the camera. Here we're going to be extracting the height and width of the image. And we're going to be needing this later to scale bounding boxes. And then here we're going to be converting the image into a blob, which is the format expected by the DNN. So we're going to be resizing the frame to 300 by 300. And then we're going to be scaling the pixel values by 1, so we're not going to make any changes. And then we're going to be subtracting the mean RGB values here. So this normalizes the input around 0, matching training conditions. And then here is where we're going to be feeding the blob into neural networks as inputs, right here. And then we're going to be performing forward propagation through the network, as you can see here. And then we're going to be receiving a detection matrix of shape 1, 1, n, and 7, where n stands for the number of detected faces, which is right here, n. We're going to be using I here. So here we're going to be iterating through each detected face, and we're going to be retrieving the confidence score of the detection here, which is a probability between 0 and 1. And here we're going to be only detecting the confidence over 0.5. So a higher confidence means the model is more confident that the box contains a face. So in other words, here we're going to be filtering out the weak detections. Only process those above 50% confidence. So here we're going to be getting normalized coordinates of the bounding box, and then we're going to be rescaling them to the original image size using W and H. We're going to be converting them into integers to draw the box. And then here we're going to be drawing a green rectangle around the detected face. So here, as before, it's going to be releasing the webcam, so it's not locked. And then all OpenCV windows are going to be closed. Let's run it and see how it works. So as you can see, it's detecting my face very well. Let's do some experimentation. So when I tilt my head upward, it's not going to work as well anymore, as you can see. But overall, it's not that bad. And you could also have access to the code using the link in the description section of this video. And that's about it. Thank you so much for watching this video. I hope you liked it and also found it helpful. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.